Welcome, ladies and gentlemen, to Integrated Math 2. In today's episode, we will be discussing Chapter 2.3.2, which is determining similar triangles. Similar to how we do triangle congruency, triangle similarity is going to be the same. We're going to use a flowchart to prove similarity. The reasons for each piece is going to be a little bit different, but that's okay. We can handle it. We're going to look at problem A real quick, and we have triangle IHG and triangle KLJ. And let's go ahead and get this flowchart going here. So what I'm going to do is I'm going to start off with let's just go and calculate some pieces here. Before I do that, I'm going to rotate a triangle here. That way it's in the same orientation. So let's see, if I rotate him and flip, I think that's going to be a 9 right there. The 12 is going to go here. The L is here. L to K is 9, and this is going to be J up here. Okay, great. I'm going to switch out my pencil real quick. I need to adjust it. Awesome. Okay, so from here, let's go ahead and get some proportionality going. Let's see if we can end up showing that the triangles are proportional. So I can go ahead and say that 16 over 12, and then I can go ahead and say 12 over 9. Let's see if these ratios end up becoming the same. They both divide into 4, so I get 4 over 3, and here they both divide into 3, so I get 4 over 3. So it looks like my scale factor is 4 over 3. And that's going to be my reason for proportional and similar sides here. So I'm going to go ahead and start off with the fact that side HI is going to be similar to side LJ. And the reason for that is I'm going to say scale factor equals 4/3. And then I'm going to go and say angle H is congruent to angle L, and that's given. And then I'm going to go ahead and say that HG, side HG, is congruent to side LK. And again, the reason for that is scale factor being 4/3 again. So I would say then that triangle IHG is similar to triangle JLK. And that's because of our good old buddy side angle side similarity. So I think that's a pretty straightforward kind of problem here, and that's pretty much what we're learning today, is how to determine if triangles are similar using flowcharts to express the idea. Let me scroll over to the right real quick. Let me go and make these two triangles in the same orientation. So X is going to go up top, Y is going to go on the left, and Z is going to go on the right. So between X and Y, 9, between X and Z, 8, and between Y and Z, 14. And again, we're going to compare it to this small triangle right here. So let's try and look at some scale factor here. It looks like we have 9 to 4. We've got 8 to 5. And we got 14 to 7. I don't think these scale factors are the same, so we can say then that triangle PQR is not similar to triangles. If I go PQR, so that's going to be P to Q, so XYZ. Okay, let me go and pause real quick and get the next problem up here. Now with this example in C here, it's often good to separate this triangle inside of another triangle into two separate triangles here. So I'm going to go and separate the large triangle, and I'm going to call him MVT. And then the small triangle I'm going to go ahead and do here, S, N, and M. So this is going to be the 9, this is going to be the 11, and this is going to be the 5. This here, it's not 2.5, right? It's 9 plus 2.5, so 11.5 right here. Now from here, if I wanted to talk about the similarity of these shapes, the sides actually won't mean much, but what I can determine is that these two angles are congruent right here. Now how does that help? Well, I can say then that angle V is congruent to angle S, and that's given. And I can say that angle M is congruent to angle M. How do I know? Well, remember, the triangle inside the triangle means that they share that same top angle right there. So it's not exactly something that's given, so you can't really put that down. I would just put same angle as my justification. And then from there, remember, for similarity, all you need is angle, angle, and you're all good. So you can say then that triangle MVT is similar to triangle MSN. And the reason for that would be angle, angle similarity. Hopefully that makes sense. I'll move on to the next problem here. Again, it's just flowcharts, so nothing too crazy. And we're back in 2-91. It says for the diagrams in problem 2-90, what are the lengths of the segments listed below? And if it's not possible, explain why not. So in A, we're looking at triangle JLK here. To find the length of JK, well, actually, that's just our good old buddy, the Pythagorean theorem, right? So I can say 12 squared plus 9 squared equals JK squared, right? And that's going to be 144 plus 81 equals JK squared. And then I get 225 equals JK squared if I add these guys together. So JK will equal 15. In part B, they're asking us to find the length of VT. Well, if you look at the diagram here, with this length here being 5, it's definitely doable in that sense where we can compare, we can set up a proportion just like we have before. We can say 9 over 11.5 on corresponding sides is equal to, again, I went from 9 to 11.5, so I'm going to do 5 over x. I'll go and call him x right here. Now I can go and cross multiply and find out what this is. It's going to be 9x equals, well, whatever 5 times 11.5 is. That's going to be 57.5. So if I divide by 9, I'm going to get x equals 57.5 divided by 9. And that's the length of VT. Now, Tn is going to be a little bit odd, because to find Tn, I'm going to find the entire length of MT and then subtract 11 from it. So here, I'm going to go and call him y, which means the entire space is going to be y plus 11, right? The small stub plus the longer thing. So what I'm going to get is if I compare the two, I'll go and say, again, 9 over 11.5 is equal to 11 over y plus 11. And again, cross multiply, right? So 9y plus 99 is equal to 11.5 times 11 is 126.5. So if I do 126.5 minus 99, I'm going to get 9y equals 27.5. If I divide both sides by 9, I get y equals 3.056. So there we go. That's how you do the side lengths of missing and similar figures. Again, it's all about that setting up a proportion and solving it. And we are here for the last problem here. It says Kamran offers you a challenge. Are the triangles below similar, and how do you know? So we're going to use a flowchart to organize the explanation. So what I'll do is I'll go and find the scale factor. So I'll go and compare corresponding sides. So I'll go and say that 23 over 23, right? Because all ZXY is the same thing as PDQ flipped over. So that's 1. And then 17 over 17, well, that's equal to 1, which means my scale factor is 1. So let's go ahead and use that as our justification for the flowchart. I can go ahead and say then that that side PQ is similar to side XY, and that's because our scale factor is 1. Angle Q is congruent to angle X, and that's given. And then I can say that side QD is similar to side XZ, and again, the scale factor of that one is 1. So based on side angle side, I can say then that triangle PDQ is not that, that's actually later on, similar to triangle, if I go PDQ, it'll be YZX. And that's going to be because of side angle side similarity. Now it says, Kamran says these triangles aren't just similar, they're congruent. Is he correct? Yes, he is. The triangles are congruent, right? The triangles are congruent, and the reason why you would know that, let's see, the triangles are congruent because of this quality right here. The scale factor is equal to 1. And when you multiply something by 1, you get no change, right? So that would be why the triangles are going to be congruent. So next thing, he wants to write a conjecture, an if-then statement about the observation in part B, and then wants to justify with some rigid transformation. So I'll go ahead and just type this one out. Basically, if two triangles are similar and their scale factor is 1, then they must be congruent. And if we had to describe some rigid transformations that mapped one onto the other, you would say to map one onto the other. Let's see, why don't we go ahead and rotate X, Y, Z 180 degrees and translate it onto PDQ. I'm going to scroll over that. Okay. And there you go. The last part of this lesson is to show you that sometimes two triangles are so similar they might as well be congruent. I think that'll wrap it up for this lesson. Go ahead and feel free to leave questions or comments in the comments area, and I will see you in the next one.